Okay, so welcome back, hopefully. So what we're going to do next is I'm going to share my screen and show you how to create some dynamic documents, how to work a little bit with our projects, and then a little bit how to work with version control. And we'll see how things go with this live tutorials. Things can always go horribly wrong. So we'll see how bad they go. So what I'll do is I'll share my screen and I'll show you something. So first, I'll show you a little bit about our Markdown, about our projects, and then about our Markdown. So this is how RStudio looks for me. So you can modify RStudio to look as you want. So on the left side, this is just where I have my script. So and then you can have any code like so this would be, I create a new object called df called cars. And on the right, I have my console. So I see if I run df, I can see what's in this object I just created. Okay. So other stuff I have hidden here. So in RStudio, you can have the environment, the files, you can have other things as well, but most of those are, I don't want to see them for now. So my recommendation when you start working with RStudio would be to have our project for each of the different analysis projects you have or different work projects. So to create that, you can go to the top right at project and you can create a new project. It will take a little bit for it to load on my computer. Any moment now. So normally it's faster. This is because it's my work computer and has lots of different restrictions and things on it. So some things take longer. So you have a couple of options here. So you can create a new project, you can use an existing directory, or you can use version control. I'm going to come back to this a little later. So let's start with a new project with a new directory. And let's say I want to create a new directory. So this will create a new folder. So let's create a new folder here. How should we call it? Okay, not a very good name, but there you go. So it's somewhere on my computer in D. Then here it asks me if I want a Git repository. So if I just click this, automatically it will create Git and it will start creating version control. I can commit things, I can link it with GitHub and so on. So again, this is one reason why you should use our projects, because it's very well integrated with other packages like Git. The other thing is I'm going to say I want this for now. The other thing is it asks you if you want renv. So if you remember, renv is this package that can create copies of packages within your working directory. So it ensures that when you come to run code again in the future, you'll have the same packages and you'll get the same results. I'm not going to do that here because it takes a while to install package locally. So I'm just going to say I want a Git repository and give it the name, and then I say create project. So if I look under files, I see that in this new project, this is the folder that it created called Reproducible. It has an object called our project file, and this is like a history of what you're doing with the project. So it remembers your options and things like that. And then another file called .gitignore. So gitignore is just a file where you say what objects you don't want to share with Git. So for example, if there's data you don't want to have in the version control or other files you want to ignore, you can just write them in gitignore and they will be ignored. So these are created automatically. So I didn't do anything, they're just created there for me. And if I want to create a new R script, again, let me give it a title. So in R, if you put a hash in front, this is a comment. You can also have sections. sections is Control-Shift-R. So this is like a heading setup. So this is, you can actually make like a table of content of your code if you want in RStudio as well. Okay, so you can run your code here. So like I did before, cars. Yeah. So I just created a new object called df that includes empty cars. And I can save this, and let's say this is my script. Or let's call it data cleaning. And if I save it, you see it appears here. Okay. Okay, so this is what our project does. It can create a folder for you. It helps you link with other packages like Renv and Git, and it's just a way for you to be organized. So if you want, you could create folders like I showed you in the slides, where you can do dir create or create it by hand, or you can create it here or directly in your Explorer, and you can make whatever structure you want and start working with it. So what I'm going to do next is I'm going to show you a little bit about R Markdown, which is this way of creating dynamic documents. Before doing that, this work computer is very strange because they actually don't allow me to install packages, but I can install them somewhere else on my computer. So what I'm going to do is change the place where R will look for packages. And I need to do this because in order to run R Markdown, you need a couple of packages that I already have installed somewhere on my computer. Okay, so the only thing it does is it just says look for packages in this folder. You don't have to do that on most computers, but if you are on a computer where you can't install packages, you can actually change the place where they are installed, somewhere where you have write access, and you can do that. Okay, so let's look at creating these dynamic documents. So you can go to a new file here, and you can say you want R Markdown. And you see there are lots of different documents you can create, but R Markdown is kind of the most general one. It asks you what you want, so you can just select. So one thing about dynamic documents, which is really exciting, is that you can write text and code, and then you can decide how to export it. So you can create a HTML or a PDF or a Word document, and automatically the software will create that for you. So it's very flexible in that way. Probably the easiest thing to create is HTML because it has the least dependencies. So that's what I'm going to do here. I'm going to create a HTML, and then you can put some info here as well, but this is kind of optional. So if you just press OK, it will create a default document for you. So you can actually run this, and it just has some things in it by default that you can change and populate. So the first part, the top of any R Markdown, is called a YAML, and this gives you kind of a description of the document. So for example, title, so let's say this is my report. So this is the title. The author is Alex. You can leave the date, and then it's just the kind of document. So this is a HTML document. If you wanted a PDF, it would be PDF, and so on. And there's you can actually include other things here. So you can have something like a subtitle. And so on. So, and you can look it up to see what are the different options that you can include here. Okay, so this is like the YAML, or the description, or like a metadata of this document. Then the R Markdown is divided into parts. One is things called chunks. So chunks are places where you can actually run R code. And then you have normal text. And the text is formatted based on Markdown. So Markdown is just a language that is where you can format text in a very intuitive way. So for example, hashtag is a title, and if you have two hashtags, it's a heading of level 2. If you have 3 hashtags, it's a heading of level 3. So it's very intuitive. If you want to put a link, you can put it between larger and smaller signs. If you want to bold it, you put it between 2 stars. So this is just bolded text. So all this part here is normal text that will be formatted based on these other options we have here. So neat will be bolded, and this will be a link. Okay. Then we have another chunk then another heading, some text, and then another chunk. Okay, so let's look at these chunks to try to understand them. So you'll see that you have this kind of inverted commas, and this is how you create a chunk. So if you have free at the beginning and free at the end, you have a chunk. Then you put the curly brackets, and here you put options for this piece of code. And the first option should always be the language you want to use. So here I'm saying the language I'm going to use is R. Setup is just it's a name for this chunk, and this is optional. I can actually delete it. And include equal to false is an option for this chunk. So include means should people see this code in the result, and include equal to false says no, people should not see what's included here. And the idea is at the beginning of the document, it should have a place where you can put options, you can import data and do other things that should not appear in the outputs. Okay, so what this R code does just says set the options for all the chunks. Echo just means if the code should be seen in the output equal to true. So that means that in principle, this code in the next chunk will be seen, while this one will not be seen because it has echo equal to false. Okay. Again, these are names we can just delete. So it's as simple as possible. So basically we have this first chunk with some options. This will not appear in the final document. Then we have some text. Then we have a chunk that just does a summary of cars. Then we have a plot, another chunk that just does a plot of pressure. And the cool thing about our Markdown is that you can actually run all of this code directly here. So if I press this play button, it will run and show me how the output will look like. So summary just gives me the summary of speed and distance, which are the two variables in cars. And if I run the plot, I just get a plot of pressure, which is just kind of this continuous variable. Okay, so I already get a feeling about how this document would look like. So if I want to create the document, I can press the knit command. So to knit means to kind of put it together and create it. So when I press it, it will ask me to save it. So let me call it report 1 to save it. And now it will render it. And now this is the report. So you see, this is the title. This is my report. Experiment is the subtitle. The author is Alex. And then the date is this. You see that I don't see the option equal to true because I said include false. So I don't see the code. Then I see this title R Markdown. So you see this is a heading 2 level title. I have normal text, then the link. So you see this was formatted as a link. You see knit is bolded because it was between 2 stars here. And then you see that the code summary of cars is shown. And the reason why it's shown is that we set the default equal to true. So that means by default, all the code will appear. Then we have the result. So that means that our Markdown run this code in R and then also printed the results. And it shows in the document both the code and the results. And then we have another title including plots. We have some text, and then we have the plot. And you see, because we put the option equal to false, it overrides the original option, and we don't see the code. We only see the result. So we just created this nice document automatically. So you see that some text is just normal text, some is formatted, and then there's R code in it as well. And you can do some cool things. So for example, let's say I want to make a table. So I can say table, what table do I want? Empty cars cylinder. So let's see, if I just run table cylinder, it will give me this table. If I put it in cable, it says, I don't know what cable is. So what we need is to load a package. I think cable is part of knit-r. So we can do library knit-r. So we can run this. And now if we run cable, it will do a nicely formatted table. So let's knit again and see the result. Okay, so now we have this extra code here that creates a table, and because it's in cable command, it's nicely formatted for us. Okay. Okay, so this is an example why you'd use it. Again, if you want to hide all the code, you could just say here equal to false and knit it again. And now you wouldn't see any code, you just see the results. So imagine you want to write a report for like a policymaker, they don't care about your R code, they just want to see the results, then you can do that. Also imagine that you import some data, the data changes, and you want to redo everything. So instead of copying and pasting and doing other things, you just rerun the document and it can use the new data and it will have the new results. We can do other exciting things. So let's say we do a regression. So LM is the regression. The formula is what is this numbers? So let's say we want to explain MPG using cylinders, and the data is empty cars. Let's see if this works. So this works. So let's save this as an object. Reg1. Okay. So let's see what happens if we include it in cable. Oh, it doesn't work. So let's write HTML. So there are some packages to create nice tables in R. So one of them is called TextReg. And one of the functions, I think it's HTMLreg. So if I run this, what it will do is it will automatically take this regression and format it like a proper publication table and print it. And if let's run this and see if it works. So you see by default, this is not formatted properly, and we need to change one of the chunk options. So if we say results as is, so the reason why we need to do this is because HTMLreg creates HTML code already. So we're telling R not to do anything, just take the result as it is, basically. And then if we knit it again, you see that we have a nicely formatted table ready for publication. So we could also modify this. TextReg and HTMLreg has lots of different options, but okay, it shows us the R square, number of observations, if the results are significant, the standard errors, all of it is done automatically. And then imagine that, okay, maybe, you want to change the regression. Let's put HP as well and just rerun it. And now we have the new results with HP as well. So you see that because you have these dynamic documents, in principle, you can either change the data or your code, and then everything will be updated. And you can keep track of everything you're doing. So you can share this with other people, and you can use it together with version control. And again, let's see if I want to do a PDF, let's see if this works. Might not work if I don't have the right packages. Let's see if this works. Okay, so this has worked, but now this is not formatted properly because we need to use, I think, TextReg. Now this is formatted for LaTeX. So you see this is, again, formatted nicely. So I created a PDF as well with the report. And this is incredibly flexible. So you can actually make automated reports. So you can do the same report for different groups and then automatically loop over it. So you can do 1,000 reports automatically. You can write books with this, create websites and other things. So it's incredibly flexible. So I would recommend you have a look at it. In the slides, there was a reference to a book that covers this. So you can have a look at that. So before we go to version control, do you have any questions about dynamic documents? Yeah, so Jamie is asking about this library. So I think by default, I think you can change the default of the library. By default, it goes somewhere like in C or depending on your operating system. And I think you can change that default. I'm kind of always reluctant to change the defaults of R, like to hard code the general settings, because I'm afraid things might go wrong at a certain point in the future. So I prefer to set the library folder every time. But actually, you can put it at the top of your code, and it's not a big deal. So if you put it here, libpaths the packages, or if you put it at the top of your syntax here, then you can just run everything and automatically this will be set up. So this is another nice reason why it's good to have code, because you can reproduce this, and you can also make it conditional. So for example, I can say if it's a particular computer, then do this. So for example, I can say check the user, and if the user is this individual, then I know it's this work computer where I can't change the working directory, and then you load this package. So you can make it conditional, and then the code would work even on my personal laptop where I don't have to do this. So yes, by default, this libpaths changes every time you close RStudio, but there's some ways around it to make it less painful than it is here. Thank you. Other questions? Okay, so let me show you a little bit about version control. So in order to use version control, and here I'm going to show you how to use Git. There are other types of version control software out there. Probably Git is the most popular one and is the best integrated with RStudio as well. In order to use this, first you need to install Git. So Git is like an independent software. It's open source. You can go to the Git website and download it. And to make sure that you have it, if you go to Tools, Global Options, if you go to Git and SVN, you should see here that you have Git installed. So it will look, I'm using a Windows computer, it will look at, if it's in program files, Git, bin, Gitx. So that's the first thing. You need to make sure that you have Git installed on your computer so R can figure it out. The second part that you need to do is, if you want to use GitHub so you can back up in the cloud, then you need to make an account on GitHub. You can make a free account, and if you are at the educational institutions, you can make a free pro account as well. And in the PDF with how to prepare for the practical that you can find on the link, you can see how to set that up. So once you have Git installed and you have an account with GitHub, you need to make the two connect. And this can be a little complicated. Again, in that PDF, I show you one way to do it using this package called use this. So I'd recommend you look at that. And then I also give you a link to an online book that you can use to troubleshoot. So now I'm going to assume that you have a link made between Git and GitHub. And one way to figure it out, you should have a tab called Git somewhere on RStudio. So if I go here on Git, you'll see I have a tab that says, oh, these are the files in this project. I can commit, I can push and pull, and so on. If you don't have this tab with Git, it means either you don't have Git installed or you didn't connect it to GitHub. So you need to sort that out. So now, assuming you have that, there are a couple of different ways to go about it. So probably the easiest way to start a GitHub project, so you can link the two, is to actually start from the website, from GitHub, create a project there, and then import it on the other side on your computer. So let me show you how to do that. So I'm logged in my account on GitHub here, and let me create a new repository. Let me call it Reprod2. You can put a description. You can decide if this is public or private. So because I have the pro account, I can decide to make this private, but you don't have to. And then you can decide if you want a README file. So I'm going to check that I want a README file. you can decide if you want to git ignore, and I say that I want to git ignore. And remember, this is the file that decides what will be shared between your computer and GitHub. And actually, this has a couple of defaults. So you can actually default to R, and it will include some files from R that normally you don't want to sync. And if you want, you can also choose a license. So in principle, because this is, kind of, in principle, it could be copyrighted software, you can decide on a license. And again, if you choose a license, there's some different license here. Some are, MIT, for example, is a type of open access license. But for now, let's not put a license, okay? So if I press create repository, it will create a GitHub repository. You see it has a README file. So what you see here, reprod2, and this is an example, this is the README file. And you see the format of this is .md. So this is a markdown document. And then it has a git ignore that it created. So if I go to code, you see that this has a link. So I'm going to copy this link and then go to RStudio. And then let's imagine, okay, I want to work on this new repository. Let me save what I did here. And I can go to project and I can press new project. Again, might take a little while. I know this is a little counterintuitive that you're making first the GitHub repository online and then you put it on your computer. It just is the easiest way to do this on RStudio. It's not the only way, so I'm going to show you another way afterwards. So now in RStudio, I'm going to select version control and then select Git. So SVN or Subversion is an alternative to Git, but I'm going to go with Git now. And then I'm going to just put the URL here. It will tell me, okay, the name of this folder will be reprod2, and this is where it will save it. And I press create project, and now automatically it will close the other project and open the new one. And then if I go to files, I see that basically I have what I had online. So I have a git ignore file, I have a README file, and now I also have our project file. So let's open the README file. So if I go to open README file, so the README file is just a markdown document. So I can format it like a markdown document. So the title is reprod2, but let's change the title. Say, okay, so I just changed the the README file. And if I save this, now I change something on my computer. I can actually commit it. So I can go and press commit. It will open a new file. So here I can say what files I want to commit. So I want to commit the changes to README. And you see here it shows with red what I deleted and with green what's new. So this is how you can figure out what are the changes. And then you can decide if you want to also save the R project. This is optional. Let's say I want to put R project as well. Okay. Now I need to say a message for this. So let's say this for change in the README file. And I commit it. And now this is saved on my computer. So this is saved locally. If I want to send it to the GitHub website, I have to press push. If I press push, it says this has been sent. And if I go to the GitHub website and I'm just refreshing the page, you see that the title has changed. So the new file is here. I also have the R project here. So I just saved and now everything is online. You can actually modify the README file directly here. So let's say some more text. You also, this is basically you're committing a change to README file on the website. So you also need to put a message here and commit. So now I changed what's on GitHub. So imagine it's like a collaborator has changed the project, and I can go back to my computer and press pull. So you see now the README file was updated and I have the new text that I put online. So this way the two, the two are communicating basically. So somebody asked if it's possible to share this as well. I think it's possible. I'm not sure how useful it is. I think you can actually reproduce it better if you look at the video afterwards, because I'm not sure what to share. I mean, this text file is not very exciting, but I'll think either to share this or to make that repository public or something like that. You can also follow the steps in the exercise, in the practical, because I'm kind of doing what's there as well. Okay, so this is one way to do it. I want to show you another way to do this using GitHub Desktop. So GitHub, like I said, is the software online. Git is the version control software on your computer. And RStudio is kind of an intermediary between these two, okay? But actually, there are other software that you can use for that as well. So one of them is called GitHub Desktop. I'm going to try to open it. So this is another version, another way to link what's happening on your computer with GitHub. So let me go to the previous project, to Reprodu1. Excellent names. So we're switching back to the other one. So remember, here is the project that I started initially on my computer. Let's imagine I want to push everything that I have done here directly to GitHub using the GitHub Desktop. So let me go to GitHub Desktop, and I can add a repository. So I can add the existing repository. I can go where I created this new one. So d10. Okay, so this is everything I have on my local computer. So I created a R file, if you remember. I created the report, the PDF HTML, and the R Markdown. So imagine I want to publish this. So it's pretty straightforward. So first I need to commit. So setup of repository. So this is another way to commit using GitHub Desktop. And then if I press publish, again, this is already linked with GitHub, so it knows what's my account. I say to keep this private and publish repository. Okay, so if I go back to GitHub and I search for my repositories, so this is the repository I created before. So imagine I want to look at the report. This is the PDF report I created before. Okay, so it's already here. And again, imagine, oh, I didn't create a README file. I can add it by pressing this button. So I can create it on GitHub. So this, it just created the README file. And now if I go to GitHub Desktop, I can press fetch origin, and it will figure out, oh, there's a change on the website that is not on my computer. So it's recommending me I should do a pull origin. I press the button. If I go back to RStudio, I can open the README file now. Okay. So again, GitHub Desktop automatically downloaded the README file I just created. So again, there are other ways to link them. So if you prefer, you can actually use only scripts. So there you can use commands to connect these, so you don't need to use any interface. But you can also look in other interfaces that you might want to use. So GitHub Desktop, I think it's more intuitive than RStudio in some ways, but it's also more annoying because you have another software. So it's up to you if you want to use it or not. But if you get stuck with RStudio, you can try that out. I think that's most of the things I want to share. So do you have any questions before we kind of call it a day? So I have a question here. Which software should we use as social scientists? Oh, that's a very, very problematic question. So people have very different opinions about what software to use. So I don't know. I have used R, SPSS, Data, M+, Latent Gold. So a couple of different software. I don't have any experience with Python. So I'm not sure. It depends who you're working with. Probably future-proof. I would say Python and R are the main software, and they're both all free as well, and they have very big communities. So those are the ones I'd recommend. But again, it depends who you're working with, what you want to do. So those, would be the things to consider when you think about software. And I'm sure if you ask someone else, they will tell you something different as well. Okay, other questions? Okay, I mean, if not, we can stop here, unless Paul, do you want to add anything? Yeah, before that, I want to thank you for being here and, surviving all this time. I hope it was useful. I'll share the R Markdown file as well with Paul, so I can put it on the website, but the video and everything will be available. So I think you should be able to reproduce what I had. And then I look at the recommended readings. Those are important bases of the presentation as well. Paul?
Thanks. No, I don't really have anything to add. I'll just urge everyone to fill out a feedback form. I'll link that in the chat as well. Anything that Alex sends to me after the workshop will go online to the website. So check back there. The video will be posted there as well, and I'll notify everybody through email when those things are online. So I would say, yeah, look for updates to the software online. Look for the feedback form, and then also the video. And then, Alex, I noted down your references as well. I'll probably put those right up on the webpage as well. I think those are cool.
That would be great. Yeah, thank you so much for having me. I'm sorry not to be in Michigan, but it's still good to be part of this, so I appreciate it. Okay, everyone, well, stay safe. Hope to see you at the conference soon, and hope to see your exciting repositories with all the cool work you're going to do. And take care. Okay.